Welcome back, class, to section 6.2, Transforming Quadratic Functions, part 3. Before we move on to explain 3b, let's look at some rules that we went over in our last video. In our last video, we looked at vertex form. Vertex form is g of x is equal to a times the quantity of x minus h squared plus k. A few things to remember. A is our scale factor. H and K are the coordinates of our vertex. So if our scale factor, which is A, is positive, our graph will open up. If A is negative, the graph will open down. If A is between -1 to 1, so if it's a fraction or a decimal between -1 to 1, then our parabola will be wide. If A is less than -1 or greater than 1, then the parabola will be narrow. If A equals 1, it'll be of regular size. Our K value will move the graph either up or down. And one way I like to think of K is when I graph, I like to keep my K value. H will move the graph either left or right. And because H is inside the parentheses, I like to think of H as a hypocrite. So in other words, you do the opposite of what you see because these parentheses lie. The coordinates of our vertex after the transformation is H and K. Now let's look at explain 3a, graph the quadratic function. And in this video, I am going to teach you a shortcut. You start off by labeling your parts. A is -3, H is 1. Notice how I said 1 and not -1. Remember, if it's inside of the parentheses, you do the opposite. H is a hypocrite. A hypocrite is someone who says one thing and does another. And K you keep. You only need 3 things to graph this parabola. Let's identify the vertex. The coordinates of our vertex are H and K. Our H value is 1. You do the opposite, and K we keep. We also need A, which is our scale factor, and our scale factor is -3. Without graphing the problem, I automatically know 2 things based off of the scale factor. I know that my parabola will open down, and because -3 is less than -1, the parabola will also be narrow. So now let's graph. You start off with the vertex. You go to 1, -2. 1 unit to the right, 2 units down. Label it vertex. After plotting my vertex, I like to plot the axis of symmetry. That way, when I start plotting my points, I can make them symmetrical to each other. Now let's plot our second and third point. What's easy about this is that once I have my second point, I automatically have my third point because my second and third point are symmetrical to each other. So for my second point, I'm using the scale factor, which is -3. We're going to go from the vertex and move 1 unit over. So let's go 1 unit to the right. And our A value is -3, which means we're going 3 units down. 1, 2, 3. Now if I have a point on the right side, I also have a point on the left side of my axis of symmetry. When you use the scale factor, you're only going to use it once. If you use it again, you'll end up with a graph that looks like a V. Remember, these are parabolas. Parabolas look like U's. And when we get into our future lessons, I'll show you how to graph more points. But for now, let's stick to these 3 points. And let's draw our graph. So let's go ahead and review a few things. This time our vertex peaks up, which means that we have a maximum. And our maximum y value is at -2. Let's label our axis of symmetry. The axis of symmetry is at x equals 1. And that's it. That's how you graph a quadratic function by using the vertex and the scale factor.